Are we ready? Okay, here we go. Here's a little video rundown of the topics on the team test, which is going to be tomorrow. That is Wednesday. All right, so one of the problems will be asking you to take an equation, a quadratic equation in standard form, and rewrite it in vertex form using the completing the square technique. One of those problems will have the a, that is the number multiplying x squared, equal to 1, so kind of a normal one, so-called. And another one will have a equal some other number, a 2, a -3, or some other number. I will ask you to tell me what the vertex coordinates are, what the domain, and what the range of that quadratic function is. Okay. I'll also have a couple of questions that are related to this idea of transforming quadratics and absolute value functions specifically, either by giving you an equation and asking you to describe the transformations, or kind of the reverse of that. I'll describe the transformations and you write the equation. And the transformations will be stretching or compressing, flipping it upside down across the x-axis or not, or shifting it horizontally or vertically. Okay? And that could apply to quadratic functions and absolute value functions. Okay, I will also ask you to solve a couple of inequalities. All right, probably be a linear inequality and maybe a quadratic inequality or two. So check your notes on solving quadratic inequalities for that. You'll also be asked to solve a system of equations. And I'll tell you right now, I'm going to have a system of equations where one of the equations is linear and the other equation is quadratic. So there'll be a couple of those for you and your team to work on during the test. And last but not least, I'm going to give you the graph of some crazy looking function and ask you to draw a picture of its transformation. I will describe a transformation symbolically, so check problem 141 out of your book from chapter 9 for an example of that. Problem number 141. And that'll be on the test as well. So you'll be drawing a graph of some transformation of a function that you don't know what it is. However, if you want to take the time to try and figure out what it is and write the piecewise defined equation of this function that you'll see, or the transformation that you create yourself, you'll get some extra credit points for doing that. Okay? So that's what's on the test. The solo test on Friday will have all of this stuff, plus possibly one or maybe two review questions like basically solving a quadratic or maybe exponential or laws of exponents or something like that, as well as one new topic, and the topic that we talked about today, which is the equation of a circle. Okay? And so here's a basic rundown of our notes about equations of circles. So the most basic, unadorned, plain vanilla equation of a circle you could possibly have is x squared plus y squared equals 1. That has a radius of 1, and the center is at 0, 0. In the equation itself, these two parts reveal certain things. The number here reveals the radius. This number is the square of the radius. The radius squared is this number here. This stuff here with x and y, that tells you where the center is. Now, in this case, the center is at 0, 0. And for example, if you had x squared plus y squared equals 9, that would also be centered at 0, 0, but the radius would be the square root of 9, which is 3. All right? So circles that are centered at 0, 0 are of this form, x squared plus y squared equals some number. If you wanted to shift the circle off the origin some direction, for example, shifting the circle 2 units to the right, well, happily, you're already kind of familiar with this kind of notation. It's x minus 2 squared, which shift the circle 2 units to the right. And then if we don't shift it up or down, then it's just y squared. And if that equals 4, then that means the radius is the square root of 4, which is 2. The center would be 2, 0, and the radius is 2. Another one, let's shift it a couple of different directions. This is 2 units to the right and 5 units up. So this x minus means to the right, y minus a number means up, and y plus a number means down. So it's this opposite idea, opposite direction idea inside the parentheses that we saw so much with vertex form of parabolas. It applies to circles in exactly the same way. So this equation is of a circle that has a center at 2, 5, and a radius equal to 4. Here's another one, x plus 3 squared plus y minus 7 squared. That center, the center of that circle is at negative 3, positive 7, and the radius is the square root of 100, which is 10. Or here's one, x plus 1 squared plus y plus 4 squared. We got negative 1 and negative 4 as the center coordinates, and the radius is the square root of 12. It's always the square root of that number, even if it doesn't have a perfect square. And this leads us to this general case here, the center radius form of a circle. X minus h squared plus y minus k squared equals r squared. And the center has the coordinates h, comma, k. Okay, so that's a little brief rundown of our notes about circles. And like I say, there will be a question about the equation of a circle, maybe a couple of them, on the solo test on Friday. Alrighty, thanks for watching. Bye.